In this video, we will be using and creating and understanding Reentrant VIs. In this video, we will create a VI that will call itself recursively to calculate factorial of a number. So let's go and create the front panel of our new VI. Let's save this VI first. Let's call it Reentrant VI. Let's create its front panel. We will need a numeric control. Let's call it N, the input number, and we will need a numeric indicator for showing the result. Let's call it N factorial. Let's connect these to the connector pane. Let's change the representation to unsigned 16. This as well. Let's create a icon. Let's clear the previous icon. Let's create a border and then N factorial. Let's go and then create the block diagram. Let's change it to indicator. So we will have a case structure. In the first case, let's go through all the cases one or for input number which is one or more. In this case, we will be calling our sub VI recursively. We will be multiplying the input number decrement this will be the input and multiply it with itself. As you can see, it is dimmed because we have to set a property for this VI, because in default mode the VIs are not non-reentrant. You cannot call them recursively, so we will have to set a property, and we will do that a little later. In the 0 case, we will be creating a constant which is 1. Let's remove this default case. We will be handling it elsewhere. We don't need a default case for this. So the next setting to fix this problem of reentrancy is to go to the VI properties go to execution and set it to shared clone reentrant execution. So these two settings are for reentrant recursive call. In the first one, as the name states, the first option is to preserve memory usage. The second one is to preserve speed. If the shared clone reentrant execution is selected, then the clones are not created when they are created when they are required. They may share memory space, but if the second option is selected, then the number of clones are pre-allocated, pre-created. This uh, introduces more memory, but if the parallel loops are calling this VI, then no jitter is introduced if this option is selected. If this option is selected and you are calling this VI from within the parallel loops, then jitter can be introduced, which is usually not what we want for real-time applications, since this VI will be created when it is required. For our case, since we are not calling this VI from a parallel loop, we can use this option safely. As I click OK, you will see that this VI is now not dimmed and the broken run arrow has been fixed. So we are done with coding. Let's clean up the block diagram and save our VI. So let's go and test our VI. If it is 0, if it is 1, if it is 2. So the code seems to be working fine. So this is how we can use recursion and reentrant VIs in our codes. Hope this helps you in your programming. Thanks for watching.